Alright, so this is help on exponential equations as well as applications of logs and exponentials. So, when we have something like this, and this is number 5, I believe, on the Go formative, we have 5 raised to 3n minus 2 equals 125. So there is 2 ways that we can do this, and that is and the first way that we can do this is the way that we did it in class. So let's take the log of both sides. So now we have log of 5 to 3n minus 2 equals 1, the log of 125. So then we can take our exponent and make it a coefficient now because of our log rules. So now we have 3n minus 2 log of 5 equals the log of 125. And then the thing to remember about that coefficient is that even though it's multiple terms, it is one term in itself, so it's 3n minus 2 times log of 5. So I want to get rid of that log of 5, so I'm going to divide log of 5 to both sides. And so now I have 3n minus 2 equals log of 125 over log of 5. So then I'm going to move up here. So now I want to continually get n by itself. So what I'm going to do is I'm going to add 2 to both sides. So now I have 3n equals log of 125 over log of 5. And then that's going to be add 2. And then again, I need to get n by itself, so I'm going to divide by 3 to both sides. And so I have n equals the log of 125 over log of 5, and then plus 2 all divided by 3. So from here, I'm going to use Desmos to get to our final answer. So if I use Desmos, we end up getting log of 125 over the log of 5 to be 3. So then from here, we have 3 plus 2, remember from over here, and then we need to divide by 3. So our final answer was 5 divided by 3, and it would be 5/3 is our answer. So going back to over here, we have n equals 5/3. Okay? So the other way that we can do this is that we can do, it's a little easier, but you have to know your powers of numbers. So our base is 5 for this one. So we want to make our base 5 for 125. Well, if we think about it, 5 times 5 is 25, and then 5 times 5 times 5 is 125. So 5 to the third equals 125. So then we can replace that 125. So we have 5, 3 into the second equals 5 to the third. And so now because our bases are the same, we have 3n minus 2 equals 3. And we can solve for n, and so we get plus 2 to both sides, so then we have 3n equals 5, and then divide by 3, and then we get n equals 5/3. So both ways, we get the same answer. One way is a little easier, and the other you can do no matter what. You can only do the second method if the bases match. Alright? Alright, so now let's move on to applications. So if $2,500 is invested at an interest rate of 6.5% compounded monthly, how much money will you have after 5 years? So 2,500 is a very important part, so I'm underlining it. So then 6.5% compounded monthly, and how much money will I have after 5 years? So because of that compounded monthly, I am going to use the equation A equals P1 plus R over N to the T. Okay? So now let's identify these variables. So we need to identify the amount of money after 5 years. So that tells me that A is our unknown and P is our principal amount, or the initial amount. That's what we're going to start with, and that's 2,500. And then our rate, well, that's that percentage. So one thing that you can always do is that our percentage is always going to be the rate. It's just that we have to convert it to decimal form. All right. Then our next variable is N, and N is the amount of times per year, and it says that it's compounded monthly. So that tells me that once a month it's compounded. Well, how many months are there in a year? There are 12. All right. And then our last one is T, so the amount of time, and that is going to be our 5. So one thing is that rate is always going to be the percentage. N is always going to be the compounded number. So you'll always have those two if you can understand that part. So now let's put that all into our equation. So P is 2,500, and then 1 plus, then R, so 0.065, and then N is 12, then N to the T, so N times 12. Now I would do this by hand, but I'm not going to torture myself. So what I'm going to do is I'm going to go into Desmos, and I'll do this line. So our equation is 2,500, 1 plus all that. So we have 2,500, parenthesis 1 plus my rate over time, or sorry, N, oops, close parenthesis, and then raised to 12 times our time. And then we get 3,457.04 cents. So my amount would be 3,457.04 cents after 5 years, and that would be my answer. All right. So now this is number 6 on that same assignment. This is the same question, but there's one thing that's different. So again, 2,500, 6.5, compounded continuously. So that is the only change with this problem. And then how much money will you have after 5 years? So because it's being compounded continuously instead, that tells me that we're going to use A equals PERT, or P-E-R-T. So again, we're going to try and find A this time, but we need to identify P, R, and T. So P is the 2,500, the initial amount. Our rate, the same as before. And then time, same as well. So again, rate is always going to be my percentage. Time is going to be that 5 years. So I'm going to go ahead and plug those in. So we have 2,500 E, and then my rate is the 0.65, and then time is 5. So again, I'm just going to go ahead and use Desmos. So we have 2,500 E, and then that's going to be raised to 0.065 times the years, and then we get 3,468 cents. So we get 3,468 cents. So that's the amount that we ended up getting. And I just want to double check that. So once you can set up the equation, you should be able to get your answer. So that's the most important part. Alright, so have a great day, and again, stay safe.